So today we'll be talking about two types of parallelograms, which are rectangles and squares. If we're going back to our flow chart from yesterday, we talked about parallelogram already. So all of the properties of a parallelogram will apply to a rectangle, rhombus, and square, which are all part of a parallelogram family. But more specifically, we're going to be talking about the rectangle and square. So these will have all of the properties of our parallelogram, but additional properties on top of that. So back to our notes. With a rectangle, our definition is just an equiangular parallelogram. So in our rectangle, yes, we have all of the properties of our parallelogram, but the additional properties of that, or characteristics, are that all angles are congruent. And in our rectangle, more specifically, when we have all angles congruent, they're going to be right angles. So we'll have a 90-degree angle on each of these corners. In addition to that, we will also have a property about diagonals. We can also say diagonals are congruent. So this entire measure of the diagonal is equal to this entire measure of that diagonal. And more specifically, we know that in a parallelogram, diagonals are bisectors of each other. So we know that this part is congruent to this part. But if all the diagonals are congruent, each of those parts are going to be congruent to each of the parts in the diagonal. So we have all four congruent measures now. Okay, so now talking about our square. Our square, and now continuing on with our square, our definition of our square is just an equiangular and equilateral parallelogram. So that definition tells us a lot. We will have all equal angles and also all equal sides. So really, this is our regular quadrilateral, right? All congruent sides and all congruent angles that we've talked about. So in our square, yes, all of the properties of the rectangle apply, and all of the properties of our parallelogram as well. Parallelogram 2. In addition to that, we can say that diagonals are perpendicular bisectors of each other. So if we were to draw that out on our square, right, here's one diagonal, here's our other diagonal. We have a 90-degree angle in each of those corners. They're perpendicular bisectors. If they're perpendicular bisectors, they also divide the diagonal into congruent measures. So that has tick marks, that has tick marks. They're all congruent to each other because it does have that same characteristic and quality of our rectangle. Okay. And also, our next property is that diagonals bisect the angles. So we'll have this angle congruent to this angle congruent to that angle, okay, so on and so forth. And because technically we know that they're right angles in the corners, right, all of these corners, we can fill in that each of these measures will be 45 degrees. Okay, let's do some practice. So here we're given that GHJK is a square with diagonals intersecting at L. Okay, given that GL is 6, complete the following statements. Okay, so all we know right now is that GL is 6. We want to find the measure of HK. HK is this diagonal here. There's our diagonal. So to find this measure, we can put in some tick marks, which I think will be really helpful. We know that the diagonals are perpendicular bisectors of each other, so GL is congruent to every other part of the diagonal. So HL will have the same measure as GL. Same thing with JL, same thing with KL. So HK has a measure of 6 plus 6, which is 12. Now to find the measure of some angles. So to find the measures of the angles, more specifically of K to L to J, we need to think about our property that diagonals are perpendicular bisectors of each other. If they're perpendicular bisectors, yes, they divide each other evenly, but the perpendicular part is that we'll have 90-degree angles in each of those corners. So the measure of K to L to J is 90 degrees. Okay, now let's talk about the measure of H to J to G. H, J to G. Like I said before, if we're talking more specifically about the part of the angle that's split by the diagonal, we know each of these angles automatically are going to be 45 degrees because we have a 90-degree angle in that corner and the diag bisects the other diagonal. Okay, in our next example, we're going to be talking about a rectangle. We're given that WXYZ is a rectangle. We know WY, W to Y, has a measure of 5x plus 1. We know X to Z has a measure of 13 minus X. And what do we know about the properties of a rectangle? What do we know about our diagonals? We know that diagonals are congruent. So we can set each of these measures equal to each other to solve for x. So we can set 13 minus x equal to 5x plus 1 and continue to solve. So we'll add x on both sides. We get 13 is equal to 6x plus 1. Subtract 1 on both sides, and we get 12 is equal to 6x. Divide both sides by 6, and we get x is equal to 2. Now we plug that back in to find the measure of WY, and it's 5 times 2 plus 1. Like WY, this green guy has a measure of 5x plus 1. We simplify and solve that, and we get it. Alright, let's try a few more example problems. For example 3, we are given that KLNM is a rectangle. We want to find x and y. There's a rectangle, yep, we're already given that we have 90-degree angles in each of the corners. With this, I'm thinking I need to find out what x is, I need to find out what y is. So let's think about all of the properties of our rectangle. So we don't have our diagonals, which we just learned today are congruent. And we also, that's not really helpful that we have 90-degree angles in each of those corners because we don't have any other label associated with that. So let me think about my properties of the parallelogram. I'm given sides, so what do I know about the side measures? I know that opposite sides are congruent. So I can set 4y plus 5 equal to 2y plus 35. And this is only because they're opposite sides. We can use all the properties of our parallelogram. So let's continue to solve for y. We have 4y is equal to 2y plus 35 plus 30. Subtract 2y on both sides. We get 2y is equal to 30, or that y is equal to 15. And we can do the same thing with x. Opposite sides are congruent, so x plus 31 is equal to 5x minus 9. We get our x's on one side, and we get our constants on the other side. And again, if you need to pause this and solve these equations, please do. Again, this is your time to check your understanding and solve those problems. Okay. Here we have example number 4. Again, I would love for you guys to try these on your own, but if you're not comfortable, that's fine. If you're comfortable, pause the video, try the problem, and fast forward to see if you get x and if you get y. So for angle A, we're given, that it's a square, and also that there's a 90-degree angle in that corner. We are given that that angle measure is 3y plus 4. So I can set 3y plus 4 equal to 90, and then solve for y. So I'll get 3y is equal to 86, and we get y is equal to 28 2/3. And now we want to set up some type of equation for x. I know that I have a square, and in a square all sides are congruent. So if I'm looking for x, yep, I have one side and a mark for another side, or a measure for the other side. So I can set those two sides equal to each other to solve for this measure. So subtract 4x on both sides. X minus 6 is equal to 7. Add 6 on both sides. X is equal to 13. Okay, and then this error analysis problem, we just want to figure out what went wrong with it. So we are given quadrilateral PQRS as a rectangle. Describe and correct the error made in finding the value of x. So if I'm looking at this problem here, I know that this part of the angle is 3x plus 14. This other part of the angle is 7x minus 4. I know it's a rectangle, so in a rectangle, we have right angles in each of the corners. So if I put those two angles together, they're going to be equal to 90 degrees. I do not know that this angle, or this line, splits the angle into two congruent angles. So I cannot set those two parts equal to each other. But what I can do is add them up to 90 degrees, which is what I'll do. Combine my like terms. Subtract 10 on both sides. We get 10x is equal to 80, or x is equal to 8. I'm describing what went wrong. I can say that the student said both angles were congruent, but should add to 90 degrees. Okay. I would like you to give number 6 and 7 a shot. Again, it's a review on parallelograms. All of the properties we've talked about before. So I would like you to set up an equation to solve for x and y in both number 6 and number 7. Number 7 you're solving for a and b. But set up and solve an equation for both of those variables. Once you're done, check them off with me and I'll give you the homework. All right. Good luck.